Alrighty, on this video, we're going to start talking about Pemdas. This should definitely be very familiar to everybody. This is something that comes up, from what I want to say 5th or 6th grade forward. So we should definitely be very familiar with this at this point, but we're going to review it, just to be on the safe side there, just to make sure that we remember. So this is our method for simplifying. I'm going to zoom in just a little bit here so I have a little bit more room to write. So to simplify an expression, that's what PEMDAS is for. This gets a little confusing when we're moving from expressions to equations and students want to apply PEMDAS consistently for solving. It's not really for solving. What it is for simplifying. So simplifying an expression, we use order of operations. Operations. So that is what we call this guy, order of operations. We follow, that's interesting. We follow the order of operations. I just realized that I double typed that, so oops. The order of operations from left to right. So you know what? We can go ahead and write that again. Why not? Order of operations, just so that it's a full sentence there. Operations from left to right. So that's actually a big one. You want to make sure that you're always going from left to right. I have this nice silly little arrow there showing you, just like you're reading, you do the same thing with math. You go from left to right in your equation. So the first piece here, the P stands for parentheses, but really it's about grouping. I'll go ahead and write parentheses in here just because that's kind of what P stands for. That's what we're really used to doing. Parentheses. Sorry, there was supposed to be an E in there. Parentheses. But it's about grouping. So it's not just about the parentheses you see here with the kind of basic parentheses, but you can also see brackets like this. And then there's also kind of more fancy looking brackets too. So we have all kinds of different pieces that we can put in there for groupings, not just parentheses. And then E for exponents. 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 I need to bring the size down on this marker because it's just very sloppy right now. Let's see. Will that help? I back up a little bit. Yes, okay, that's a little better. Exponents. It was just the chisel marker was a little too much. And then multiply or divide. I said X. We don't really use X anymore. We use the dot or kind of just smushing things together, like, if we have a variable and a number, we just smush them together to show that it's being multiplied. But X is one of those kind of iconic things that we use for multiplication. So a lot of the time when we see a big symbol or diagram, we see that X still. So it's multiply, or divide from left to right. And I'm putting them together because this step goes together. You don't want to do all multiplication and then all division. You want to go from left to right, multiplying and dividing in order, because that will change things if you don't do that in order. If you kind of do all the multiplication and then go back and do all the division, you won't get quite the right answer there because you'll have changed some of the operations. And then this is addition or subtraction. Subtraction. Again, from left to right. This one's not as crazy, but a lot of the time if you're not paying attention going from left to right, sometimes it can mess things up with the subtraction. Because you might accidentally move that negative sign to something it's not supposed to be moved to. So this is our order of operations. And there's a little mnemonic to help us remember this. It's please excuse my dear Aunt Sally. Oops, why did I put an E on Sally? That was weird. Sally. So this just helps us remember because it's P for parentheses, E for exponents, M for multiply, D for divide, A for add, and S for subtract. So please excuse my dear Aunt Sally. That's just our little silly saying to help us remember the order of operations, because each one of the beginning letters there stands for the operation in that order. All right, so let's go ahead and practice these. So order of operations with whole numbers. So again, we're going to go from left to right. And we want to go through and think about it. Do we have any parentheses in here? No. Do we have any exponents? No. Do we have multiplication division? Yes, we do. So I have this division happening here, and then I have this multiplication happening at the end. So I'm going to go 4 divided by 2, because that's the first thing I come to, and then plus 8 plus 3 times 5, that's 15. So I did both of them at the same time. I have 7 now and I have 15 because I went from left to right. Okay. Some students, I understand you need to kind of slow down a little bit more and look at this and go, okay, it's 14 divided by 7, or 14 divided by 2 is 7, plus 8 plus 3 times 5. And we're not going to use this times symbol very long, because once we start putting our variables into our expressions and equations, we don't want that x there anymore because that gets confusing. Is it a variable or does it mean times? So with this one, you can then move forward and do your multiplication. So you don't have to do it all in one step, but you are welcome to. It just depends on your level and what you're comfortable with. All right, so now that we're here, we can go to addition, subtraction, and we only have addition here. So we have 7 plus 8, that would get us 15, plus another 15 would get us 30. So either one I do of these, I'd get 15, and 15 equals 30. So in this case, it's not really going to hurt anything if I did 8 plus 15 and then added 7 to that. When you're doing all addition, you can kind of group numbers that are a little bit more compatible. And 7 plus 8, that gave me 15, 15 and 15. It's just kind of 15 times 2 if we're thinking about repeated addition, so that gives me 30. So it just kind of depends on whether or not there are compatible numbers to kind of group. And by compatible numbers, I mean they make kind of nice numbers, like they go to 10, 15, 20, something like that. So when you add them together, they kind of make a nice number to add to. All right, so the next piece here, we have order of operations with whole numbers and grouping symbols. So now they are going to throw the grouping symbols in here. So each time we have a new set of grouping symbols, we have to start order of operations again. What did I do the or for? Oh, silly me. It'd help if I was paying attention. Start PEMDAS, or order of operations, because that's what it's called. I just jumped forward and thought it was just order of operations there. Or again, to simplify. Whoops, almost forgot the F. Simplify inside the grouping symbols. All right, so what does that mean? So down here we can see I have 42 divided by, there's these brackets with all of this information in, and then I also have parentheses in here. So what we always want to do when we have more than one grouping symbol is go to the innermost grouping. So the innermost grouping is the 20 minus 17. So I'm going to go 42 divided by 9 times, and I'm going to simplify this innermost grouping first. So we're going to work from the inside out when we have grouping symbols. So in order to simplify, to move past parenthesis, I need to simplify everything within that parenthesis, and then I can move away from it. So in here I have 20 minus 17, and I have 3. So really I don't need the parentheses anymore. Okay, so I can actually take the parentheses away and just write 3 minus 20 like this. Once I'm down to one number within the parentheses, they're no longer necessary. So now I can deal with this other set of brackets. I can't do anything with this 42 until I've completely simplified everything inside of this grouping symbol. So I'm going to have 42 divided by, and inside of here, now I'm looking at the parentheses, I'm looking at the brackets instead of the parentheses with the grouping symbol. I don't have any exponents, but I do have multiplication or division right off the bat here. So 9 times 3, that's 27 minus 20. So now I can move to addition, subtraction. So 42 divided by 27 minus 20, well, that's going to be 7. So now I'm down to one number. I don't need to put the brackets there anymore. They can kind of disappear, drop away. There's no need for them anymore. So now I can do 42 divided by 7 because there are no more parentheses, exponents. There's division here, no multiplication, and there is no more addition or subtraction. This is the last step, which is going to get me 6 when I divide. All right, so again, just kind of be aware, multiple groupings. You kind of go to the innermost grouping and work your way out but every time you're in the grouping, you go through the entire order. Make sure you use everything within there. So I do parentheses, and I didn't have exponents, multiplication, division. I only had addition, subtraction in here. That's why we went straight to the end. But then when I went out to the brackets, I had a few extra steps. So just be aware of that. Every time you move out into a new set of groupings, you kind of restart PEMDAS. All right, let me zoom out a little bit because this one's a little bit too big for our screen. Okay. So now we're going to do order of operations with whole numbers and exponents, and this is the advanced. I think you're going to get the basic one and the advanced one. So we're just practicing the advanced one on this video. So we're going to evaluate. That means we're going to actually go through and say, what does it equal? I know we don't have an equal sign here, but we can evaluate this based on, what do we know about this? So remember, 8 to the second power, that means 8 2 times minus 3 plus 2 times 4 2 times. So it's going to be 4 2 times like that. So I've kind of expanded it out just so you can kind of see it all. So now we can go through and we can start working on PEMDAS. So we're going to do the grouping here first. So I have 3 plus 2 times 4 times 4. So I'm in the parentheses. I don't have exponents inside the parentheses anymore. I technically do, actually, because that's what this is. This is my exponent. So I would do that first. So I would go, I'm going to go 8 squared instead of continuing to write it out expanded. So 4 times 4, or 4 squared, is 16. And now I can go to multiplication division. So I have 8 squared minus 3 plus 32, because that's 16 times 2 is 32, because I just did the multiplication here. And now I can go to addition, subtraction. So I have 8 squared minus 3 plus 32 is going to be 35. But since I'm down to one number, I really don't need the parentheses anymore. You can drop the parentheses and just go 35. So now I'm going back. I'm kind of going back to the beginning of PEMDAS because I'm outside of the parentheses. So I'm kind of restarting. I don't have any more parentheses, but I do have another exponent. And you could have done, ooh, what is my pen doing there? You could have done this one, honestly, at any point. It wouldn't have hurt anything to just fill this one in, but I waited until we got done with that parenthesis to follow the order. So we have 65 minus 35, sorry, 64 minus 35, and that gets me 29 when I do that last subtraction. So again, just make sure you're paying attention to that order. Parentheses, and then inside the parentheses, exponents, multiplication, division, addition, subtraction. Once you get outside of those parentheses or that grouping, do it again. Okay. All right, so order of operations with integers. So now, when we multiply or divide, that's a Y, or divide two negative numbers, negative numbers, they switch to a positive. Well, why is that? We can think of the first negative sign as opposite of. And that's actually really what negative is telling us. It's the opposite of something. So the opposite of negative is positive. So if I'm taking a negative of a negative, well, the opposite of a negative is a positive. That's why it switches signs. Because it's really meaning, it's asking us, what is the opposite of this number? So now I have negative 8 minus negative 12 divided by 4. So this minus negative 12, that's definitely going to change things. Because this is that minus negative. It's the opposite of negative 12. So I have negative 8 plus 12 divided by 4. So I can kind of simplify that a little bit by just paying attention to that double negative. And whenever I hear minus negative, that works. It also is if I'm doing, negative 1 times negative 2. This also is kind of the opposite of. So I'm saying, what is the opposite of 1 times negative 2? Well, the opposite of 1 times negative 2 would be positive 2. Okay, so just if you can kind of think of that first negative as the opposite of when we're doing that. And it's the same thing if I was doing a positive 2. What is the opposite of 1 times 2? Well, 1 times 2 is 2, so the opposite of that would be negative 2. So it's just that idea of that opposite of. All right, so now we're going to do Pemdas. I don't have parentheses, I don't have exponents, but I do have a division. So I'm going to go ahead and divide here. So I get 3, 12 divided by 4 is 3, and then negative 8 plus 3 is negative 5. When you're doing integers, make sure you're paying attention to that idea of negatives and positives. And I know we've done things in class before. I do kind of like the algebra tiles when we've done those before because it's a very cool visual. And it just helps students kind of remember how to do this type of subtraction because I have a lot of students struggling when it's a negative and a positive. So if I have 1, 2, 3, 4, 5, 6, 7, 8, and I put them in red, so they're 8 negatives, like this. And then I have, and I'll do it in yellow, I guess, 3 positives. So I have positive, positive, positive like this. Well, negatives and positives cancel each other out, meaning that 1 negative and 1 positive goes down to 0, it's gone. So I can kind of cross them out and say, well, what's left over? There are 5 negatives left over, so negative 5. Okay, so this is just, algebra tiles are a very cute, kind of, I don't want to say cute because that makes it sound a little like silly, but it's a very nice way of seeing things visually. So if you're having any trouble as far as, figuring this part out with subtracting integers from each other, you can always use a very quick little visual like this to kind of help you know what is actually there, can I see it, and then what do I need to take away. All right, so let's go ahead and go try that on Alex.